In this video you will see how I built a full-stack open-source Spring Boot plus Next.js application starter kit that includes authentication, email sending, S3 file uploads, Oauth2 login and more. You will be able to find the link to the repository in the description, but I would recommend watching the video in case you are planning to use the starter kit for your next application, because it will help you gain a deeper understanding of how it works. I promise I'm not going to waste your time by explaining what is Universe, how the first computers were made, and how did we get to this point. I tried as much as possible to keep the video as short and concise as I could. You will also have sections in the video timeline so you can skip any part that you don't care about. Let me just quickly show you what the application looks like before we start coding. So let's start this demonstration from the login page. You will see here that we have support for email password login, and we also have these two buttons to log in with Github and Google. So now before we try to log in, let's first create some user account. Keep in mind that we have validation both on the frontend and the backend. So for example, if I misspell the password confirmation, I should get an error like this. But to showcase the backend validation, for example, if I will be using the email address that is already in use, and we click register, we will get the message like this, which says user with this email already exists. Let's switch back to the demo2@email.com, and now when we click register, we will get a message that the account was created and verification email is sent to this email address. And because we are using a local SMTP server, which is MailPit, we can just go here to MailPit and see the email that was sent to us. So if we now click the verify email link, we will actually be redirected to the backend. Backend will verify our account and we will be redirected back to the login page. So if we now use the credentials that we used to create our user and we click sign in, we will get bad credentials, and that is because I already forgot my password. So we want to request a password reset. So on this page we will just use the same email address that we used previously and we will click this link. So now going back to MailPit, we should have received another email that is going to have this reset password link. So if we click here, we will be redirected to Frontend where we can specify our new password. So if we update the password and go to login, we can now hopefully log in using our new password. Now this is the user's profile page, and from here we can update some of our basic information such as logo, first name, last name, and our password. So let's now try to update the logo. We will use this image and you will see that it updated successfully. There isn't much more that you can do as this user. Basically you can just log out, but we also have admin users and you can define those through your application properties files and they will be created automatically on application startup. Before we check those, let's first verify that the login with GitHub works. So if we click here, we will be redirected to our login success page and then to our profile page. And here we see that we have this connected accounts section as well. And this is now showing GitHub for this user. But for example, if this user had a Google account that uses the same email address, then we could log in using Google as well and we would be logged into this account. Now let's log out from here and let's now try to log in as admin user. And the only thing that changed in here is this admin button, which is just a drop down that has this users link. And this will lead us to this page where admin users will be able to see all the users of the application. We have this simple table and very simple pagination. To get started, I have prepared some starting point for our backend and frontend code. And as you can see on the screen, I have some project root directory, which is in my case called Spring Boot Next.js starter kit. And inside we have backend, frontend and infra directories. I will guide you through how you can create the same. So basically we are at the same starting point and then we will jump straight into coding. So for the backend, what you want to do, you want to go to Spring Initializer and then you want to basically copy the settings that you see on the screen. It's not that important that you select all the options the same as you see on the screen. For example, if you prefer Gradle, then you can choose Gradle, of course. But I would recommend that you keep it the same or similar unless you really know what you're doing. The most important part is the dependencies, and these are the starting dependencies that we will start with. So we have Spring Web, Spring Security, Data JPA, Lombok, Mail Sender, Auth2 Client, MySQL Driver and Validation. And with that, once you click the Generate button, you will download the zip and then you can unzip the file and copy it to your project root directory. In my case, this is the backend file. Now for the front end, you want to do something similar. You will go to the nextjs website. You can click here on the get started and then installation, and you want to copy this line to your terminal. So you will come here to your project root directory, open a terminal and paste in this command line. So it will ask you for a project name, and after that you just select all the default options, unless again you know what you're doing. One last directory here that we have to cover is the infra, and we need this because, for example, we need a locally running database that our backend will be connecting to, and we will use Docker Compose to spin up one. So I will now just quickly show you. So as you can see, we have just defined a database container. It's created from the MySQL image, and we just assigned some user and root password. It's also going to be port forwarding our 3306 on localhost to the containers 3306. Now to start up this container, you will want to open a terminal in the directory where the Docker Compose file is. So in my case, as you can see, I'm in the infra directory here, and you will want to say Docker Compose up. D stands for detached. So once you do that, in your case, you will maybe have to download the image first, but you don't have to really do anything yourself. It will be done automatically. And then to check if it's actually running fine, you can just say docker ps, and you should see that the status is up. Now let's officially start the first section, which is going to be called user registration flow. To start with, let me first explain the folder structure that you can see here. Basically, we will be splitting our code based on the functionality. So for example, we have Auth, which is now currently an empty package, but it will contain all the code that is related to authentication. Then we have a config folder, which might have some global configuration classes. Then we have email, where we will have anything that is specific to email sending. Then we have entity package, which currently has this abstract entity class, which we will come to in a second. S3 will contain all the code that is related to S3 file uploads and stuff like that. And for this section, we will mostly be working within the users package and also the util package. But to get started, I think it makes the most sense to start with the user entity. And as you can see, it's just a normal entity. It has an entity annotation, getter, and no args constructor. But one thing that stands out is it doesn't have a primary key defined, and that is because we have defined that as part of this abstract entity class. And we have done this just so we don't have to define this primary key for every new entity that we create. So we are just extending the abstract entity, and we are defining some additional fields that this entity will have. So we have email, password, first name, last name, verified, which will be false by default, and a role. A role is an enum that currently has two values, user and admin, but you can easily add more values. Then we have a constructor that is taking a create user request class, which we call data here, and we are then creating the user instance based on this data. One thing that stands out here is that we are somehow injecting a bean of type password encoder into the entity. We wouldn't usually be able to do this because entity is not a bean itself, and that's why we created this application context provider class. And basically what it does, it just has some static context field here, and we set the value of this context in the set application context method here, and this will get invoked once the application context is created. And basically we can do this because we are implementing the application context aware interface. And then we have some two static methods that we can use to get the beans from the context here. And this is exactly what we are doing in this constructor. We are getting the password encoder bean. Why? Because we need to encode the password before we save it to a database. Now, some people might not like this approach, but I like this more than, for example, doing the password encoding in some service layer and then passing that encoded password to this constructor. Let's move on now from the entity, and let's take a look at the user's controller. And as you can see, it's just a normal REST controller. It is defining a request mapping at path API/users. It is injecting some user service which we haven't looked at yet. but we will see it in a second. And it has some comment here. It's used for registering a new user, and that the user that will be created will have the default role of user, and that the verification email will be sent to the user. So we have a create method annotated with post mapping, and it is expecting a request body that is of this type, and it also has to be valid. We will go back in a second to see how this is implemented, but let's now take a look at the create method. Basically, we are using the constructor that we just looked at previously. We are creating the user based on the request data that we received, and then we are persisting the user to database. At this point, we would like to send a verification email, but we don't have that implemented yet, so it will be done in one of the later sections. And then we are just returning a user response, which is another data class here. It just takes a user entity and it builds some response object that we can send back to the front end. Now let's go back to the controller again, and as we said, we expect this class to be validated because we have this valid annotation here. But if we take a look at the validations defined on the class, we will see that most of them are, you might be familiar with. They come from the Jakarta validation constraints, as you can see, but some of these are actually custom constraints, such as password match and unique. So now we will go through what those are and how they are implemented. Password match is self-explanatory. It takes two values, password field and password confirmation field. The values we pass here must match the field names on the class that we define this validation on. So here we are saying that the password and password confirmation must match, otherwise the validation will fail. If we take a look at the implementation, you will see that it's quite simple. We have two fields defined here, which is password field name and password match field name. And we set these values from the annotation. So this will be set to password field name and this will be set to password match field name. And then based on these two values, we are getting the value from the actual instance of this class. So we are getting the password field value and the password match field value, and we are checking if they match. The next custom annotation that we have is the unique. What we are doing here is we are checking if the provided email value already exists in the table name user for the column name email. This is basically an equivalent of database unique constraint, but it is much easier to handle this exception because we will also have a global exception handler that will handle all validation exceptions, so this will be handled together with that. And if we take a look at the unique validator, here we will see that it's using the JDBC client, selecting all the values from a table name where column name is those table name and column name that we provided. And with that, I think we covered all the classes, but if you would start the application now, it would fail unless we fill out these properties. So we need to define data source, URL driver, username, and so on in order for our application to be able to start up. And the way I did it is I defined some custom properties here for our database name, username, password, host, and port. These match the values that we defined in the Docker Compose file, and then we are just reusing those for the Spring data source related properties. For the Spring JPA Hibernate DDL Auto, I recommend you to also use updates. Some of you may ask, but why don't you use Flyway or Liquibase for managing migrations? During development, it would be just slowing you down. You will want to implement Flyway or Liquibase once you have your first version of the application deployed. The next time you want to make changes to the application, and maybe you also want to change some entities or create new entities, then you will want to change this from DDL Auto to none, and you will want to implement Flyway or Liquibase for migrations. That is pretty much it. As you can see, I have already started my application and it is running on port 8080, and this is pretty much the end of this section. But as I said previously, at the end of each section we will be having a small demo to see if what we have made actually works. So I have prepared here a Postman collection that will also be part of the repository, but what we want to test here is if the new endpoint that we created for user registration works. But as you can see, it does not work because we are getting 401 unauthorized. Now this happens because we have included Spring Security, and that comes with some auto configuration which will by default not allow access to any endpoints. But setting up security configuration should not be a part of user registration section, so In the next section we will be creating the basic authentication configuration so we solve the problem that we currently have. Okay, so let's now start by implementing some basic security configurations so that we can solve the problem that we had previously, where we couldn't really invoke our newly created endpoint to create a new user. If you remember, we were getting a 401 unauthorized response, and that is because Spring Security comes with default auto configuration, which does not permit any endpoints without authentication. So what we want to do here, we want to first start by creating a new configuration class, which we created here in the Auth package called security configuration. And as you can see, this is a configuration class, and we also have this enable method security annotation, which isn't really important right now, but we don't want to forget it later on, so we put it here now. Inside you will see that we are injecting this application properties class, which is also a new class that we created now, and let's see what it is. It is just a configuration properties class which will map the properties from our application properties file based on some prefix, and for this specific example is based on the app prefix. So if we go back to the application properties file, we will see that we have a bunch of these properties with app prefix. But right now we are only interested in this one. So this is the new property that we added in this section, and we don't really care about these properties, at least not within this application properties class. And then what we want to do next, we want to create a security filter chain bean so we can override some of the default settings. For example, we say that we want to allow all requests that are aiming for this API/users endpoint with a post method. Then only temporarily we will also disable CSRF protection, but we have a to-do left to implement it properly later on. And we are also setting up course configuration by invoking this course configuration source method, and that will use the application properties getAllowedOrigins property, which will be mapped to this property that we added here. And the rest of the properties are hard-coded, so we want to allow all methods, we want to allow all headers and credentials. And that's it. We then just say HTTP build, which will build the security filter chain. Other than that, we are also defining a bean of type password encoder. If you remember, we were already trying to use this bean in the user entity, and the request that failed for us because of the default security configuration would fail anyway because we did not have this password encoder. And you would probably think that if we now run the request again, that this should work. But if we try to run this request, it will fail again with this status 403. But if we go take a look at the logs, we will see that what actually happened is that our validation failed because the password needs to include one capital letter. But still the error message that we are getting is 403, which doesn't look good, but we don't really see what is actually happening. Why is it 403? And this is why I also added to application properties file these different logging levels that you can set to debug some issues, like for example this one that we're having right now. So if we just go and uncomment this logging level for Spring Security and set it to debug, and then we restart the application, we should have more information to learn about why exactly the 403 was being returned. So let's run the request again. You will see we get the same response, but this time we can also see there are some logs that we didn't have previously, and they can maybe help us to find out what is causing the issue. And here we can already see again validation fails, and because the validation failed, Spring Framework is trying to redirect us to error page, which is, again, I said before, every endpoint or every path is going to be protected by default, and that will fail. This is why we are getting the 403. So how do we want to handle this? First, we want to create a global exception handler, and in this exception handler, one of the things that we will be doing is we will be handling method argument not valid exception, which is the exception that is being thrown by the validation framework. The way we will handle this error is that we will build some HTTP error response and pass it back to the response, and not trying to issue a redirect to the error page. Now we have implemented a global exception handler, and this is the class here called exception handler, which is inside the util package. And as you can see, we have annotated this class with controller advice, and it also extends the response entity exception handler. Then we override this method handle method argument not valid, which is going to handle the exceptions that were being thrown previously. It was trying to redirect us to the error page. And so now, because we have overridden this method, we can basically say what we want to happen here, and we no longer want to redirect to the error page. Instead, what we want to do, we want to build some HTTP error response, as I said previously, and then we want to return that as the response to the request. And so now if we take a look at this HTTP error response, we will see that it's a simple data class. It only has a few properties like message, status, errors, and general errors. You will later see what the difference between general errors and errors is, but in essence it is just the difference between field level errors and object level errors. And then we also have two static methods here that we can use to build this HTTP error response. We have a version where we pass in all the parameters, and then we have another version where we only pass in a message and a status. So back to the exception handler, we see that we are creating here HTTP error response with a message unprocessable entity and a status of 422, and then we also pass those validation errors and general errors to the response as well. We also then added another exception handler which will handle all other exceptions, and in this case we will just be returning a response entity with unexpected error message and status of 500. So if we now start the application, it should start up fine, and we should be able to go to Postman and send the request again. But this time you see that we are no longer getting the 403 forbidden, and that's because we are no longer being redirected to the error page. Now instead we are getting a readable, meaningful error message that we can take action upon. So this error message is saying to us that the password must contain at least one uppercase letter, one lowercase letter, and one digit, and we can see already that the problem is that we don't have an uppercase letter, so let's fix that. And if we send the request again, we will see that it will succeed. Okay, now to wrap up the user registration process, it would make the most sense that we implement sending the verification email. If you remember, we previously had a to-do here left to implement verification sending. And now you can see that we have a method here that is called send verification email, which is going to pass in the user that we just created. Inside we can see a new entity that we are creating called verification code, and we are creating this entity by passing in the user. We will take a look at the entity in a second, but let's just go through the rest of this code. So what we do next, we also set the verification code relationship to the user side, and then we save the verification code. The next thing that we do, we are creating this send welcome email job. This is also a new class that we created that will work together with the background job request in queue method. Now this is coming from the, as you can see here, it's coming from org job runner scheduling. So job runner is a new dependency that we added, and I would recommend you to take a look at their documentation if you want to learn more about it and how it works. We will only go through some basics in here, and I will not spend much time explaining how all this stuff works. But let's take a look at the send welcome email job. That's a new class that we created here in the jobs package. It is just a simple class which implements a job request, holds one field which is called user ID, and overrides this method called get job request handler. This method only tells job runner which handler class should be responsible for handling this job. If you look at the documentation on job runner, you should easily be able to find more information about this, but for example, one thing that you should remember is to keep the jobs as simple as possible. So we could pass in the whole user object in here instead of just passing a user ID, but in their documentation they will recommend that you do not pass entire objects like that, because this has to be serialized and it will be saved to database, and you don't want to save an entire user. Let's come back and take a look at this verification code entity, and we can see that it is just again a normal entity, which in our case is extending the abstract entity. It holds a code, an email sent flag, and a relationship to the user. And then in the constructor we are generating the code using this random string utils from org Apache Commons, generating random string of 6 numbers. And because we also want to be able to access verification code from the user side, we have defined a relationship from that side as well. So we here have 1-to-1 again, but this time it says it's mapped by the user property from verification code class. Now let's look at the send welcome email job handler, which implements job request handler coming from job runner package, and it is taking here generic type, which is the type of the email job. We are injecting user repository, verification code repository, template engine, email service, and application properties. This is a new one for us, and this is, I think, also a new one for us. So we will take a look at those in a second. But because we already mentioned that we also included job runner, and now we also see this Spring template engine, let's first take a look at the POM file to see what changes we made there. Here we see that we added the job runner dependency, Apache Commons, Commons line 3, and Spring Boot starter time leaf. And this is what makes it possible for us to inject the Spring template engine. Now let's go through the run method. So we see here that we are receiving send welcome email job as a parameter. And what we want to do, we want to first check if we have the user with the user ID that is defined by this send welcome email job. And in case we do have a user verification code is not null and verification code email is not already sent. In that case, we are sending a welcome email by invoking this function. So inside this method, first we are creating a verification link, which will be our base URL and then /auth/verify email, and we pass in a token as a parameter. We will later create a mapping for this page on the backend. We then create this context, which is something that is time leaf related, and then we put some variables inside the context. For example, we put the user, verification link, and the application name. We need all these variables to create the email template, and you will see that this is what we are doing next. We are using the template engine, which we mentioned before, and we are invoking the process function on that, where we are specifying the name of the template that we want to use, which in our case is going to be welcome email, and we are passing in the context. If we take a look at the email config class, we will see that we are defining some template configuration for time leaf templates. So if you take a look at the left side in resources, we have this email templates or mail templates folder where we are going to place our mail templates. Coming back to the send welcome email method again, we see here that we want to process the template with name welcome email, and let's now take a look at that template. And here we see that it's just a basic HTML file with some time leaf syntax. After that, we are using the email service send HTML message method, which we haven't looked at yet. And if that is done successfully, we have to update the email send flag on the code to be true, so it doesn't get sent again. Before we take a look at the email service, we see that we added some new properties to the application properties class. This is the class that we looked at earlier, but it only had this property here, allowed origins, and now you see that we also added application name and base URL. Okay, now I think we can take a look at the email service, and here we see that it is just a normal service where we are injecting the email sender. This class is coming from Spring Framework Mail Java Mail, and inside we have two methods. One is called send HTML message, and the body of this method is pretty simple. There is no need to go through it step by step. For any additional details that you would like to know about, you can always refer to the documentation from this package here. Just to explain the difference between the two methods, this one is going to be used when we want to send HTML messages. So those are messages that we will use our templates for. For example, welcome email, it has a template which we process and then we pass an HTML body here. If we do not have a template and we want to just send some very simple email, we can go on with using this method, which is again going to take a string, but this time it doesn't have to be an HTML body, it can be just any string. Now before we move on, I just want to quickly go back to the user service and explain why are we using these jobs here and why is it necessary. Well, it's not really necessary. We could be sending this synchronously. But the way this will work now, because we are creating a job and then we are enqueuing a job, it will not be done in the same thread as the rest of this code. So the response can be sent already before the email is sent. So here, once we enqueue the job, we will immediately go to the next line and we will send the user response, and in the background job runner will take care of invoking this job once it gets to the front of the queue, and then the email will be sent. Okay, now I think we covered all the classes, but if we would start the application now, we would see that it would not work, and what we didn't yet cover is the application properties. So we can see we have some changes in here. Two of them we already mentioned. So application name in our case will be starter kit, and base URL will be the root URL of the backend. But we have some additional properties here that we defined, and two of them are for job runner. So we have to enable the background job server in order for job runner to be working. And you can also enable the job runner dashboard if you want to take a look at the jobs in a nice looking web UI. And then below that we have some Spring Mail specific properties that we need to define for our mail sending to actually work. So we are defining a host, port, username, password, and some other settings here. And now you are probably wondering, where are these values coming from? And that would be a good question. We also made a change to the Docker Compose file because we want to be using a local SMTP server in development. For that we will be using MailPit. It serves as a local SMTP server, but it also has a nice looking dashboard that you can access, where you can see all the emails sent through the SMTP. And you can see here that it will be running on port 8025. So after we added this, you will have to run Docker Compose up again in order to start the MailPit service, which I have already done. And once we've set all these properties up as well, we should be able to start the application. And we are just going to go back to our Postman and try to invoke this request again. So now what we expect to happen is when we create the user, we should see an email sent through the SMTP server to this user, which also contains a verification link. So if I click send here, we will actually get 422 unprocessable entity, and this is good because if you remember the unique constraint that we created, we are checking if the user with this email already exists. And if you also remember, we successfully invoked this endpoint once before, so the user with this email already exists. To solve this problem, we will just remove one of the parts of the email and invoke the request again. As you can see, we immediately got the response, but how can we now verify that the email was sent? We can go to localhost 8025 and you will see that the email was sent to this user that we defined in the request. We also see that the content of the email is exactly the content that we defined in our template. And we also have this verify email. If you look at the bottom left corner, you will see that it is going to /auth/verify email, and it is passing the token properly. We do not yet have this endpoint implemented, and we will do that in one of the following sections. Okay, so now that we completed the user registration flow, the next logical step is for us to implement authentication. And so in this section we will cover that. You can see already that I made quite a few changes here, but we are going to start with the Auth controller. We want to have some API endpoint called, for example, login, that we will be able to invoke from our frontend, and that will authenticate our user if the provided credentials are correct. And it will also set a session cookie to the response, and then we will be able to reuse that cookie in future requests. In this Auth controller we already have this login method. We also have two other methods here, such as me, which is going to be used for getting the currently authenticated user information, and then we have a method for logging out as well. For now, let's focus on the login method, and here we see that we are invoking the auth service login. So in this login method we see a bunch of Spring Security specific code, and I will not be explaining this code because it's library specific, and libraries usually have some kind of documentation that you can go to and learn about the details. I also actually went to the documentation and found out what they recommend and how they recommend doing this. So here, if you go to Spring Security, you will be able to find this session management tab here, which you can visit, and you will see that this is basically the same implementation that we have in our code. So if we go back to the login controller, we just see that we are returning a response entity. Okay, so it doesn't have any body, but what will happen here, the response object will be set with a cookie that will be created by Spring Security in case the authentication was successful. We could almost test this, but before that we have to make some changes in the security configuration class, and here you see that we added this new request matcher for our login method, which we want to permit to all users. Next, what we did is we added a username password authentication filter, and we added user details service. And again, this is not something that we will cover in more details in this video. I recommend you to take a look at the official documentation first, but if you prefer videos, I also have a video that covers this topic on my channel. Now, one more thing that we did here is we exposed the authentication manager as bean, and that was needed because, as you already saw in the Auth service, we are injecting the authentication manager and we are using that to authenticate the user. And now this is also not something that I just made out. You can find how to do this yourself using their official documentation. Here in the username password authentication, you will see exactly a section that explains how to do what I just did. One additional thing that we had to do for this authentication manager is, because it requires a bean of type user details service, we had to create one, because as you can see here, we are trying to inject this bean. If we take a look at this interface, we will see that it's coming from Spring Security, and we actually provided our own implementation of user details service. And we see here that it only has one method called load user by username, which in our case username is actually an email. We are using our user repository and calling a method find by email. So if we take a look at this repository method now, we will see that it's just a simple query which will try to find the user based on the email that we provided. You might have noticed that this method expects to return a user details object, and here we are returning a user object. But if we take a look at the user class, we will see that I actually implemented the user details interface on this class. User details interface comes with a few methods that we have to implement, but for most of these I hard coded some return values, except for the get authorities where we return our role name, and get username where we return our email. Now back in the Auth controller, let's cover the rest of the methods here. So the get session is also calling the Auth service get session method, and if we take a look at that, we will see that we are trying to get a user, which is the currently authenticated user, using this security util class. If we take a look at the security util, we will see that it's just a normal util class. So if we take a look at this method get authenticated user, we will see that it is returning a user, and it is getting the user from the security context holder. Now we could do this anywhere without using this class, but what it will require us is to typecast the object, which is the principal, to our user class, and this is just a helper method that will do that for us. As you can see here, we check if the principal is an instance of a user, and then we return the user. If the user is not found in security context holder, then we will log some error, and we will throw this API exception, which is also a new exception that we added. So you will see here that it is created in the exception package inside util. Now the idea behind this API exception is that we want to have one unified exception that we can throw, which can be represented as an error response, and then we will handle this exception globally. So for example, in any of our services or controllers, we can just throw this exception and we know that it will be handled properly. And we know that because we created this new exception handler here in the exception handler class, which will handle the API exception. So in our specific case here, when we are requesting the authenticated user and we cannot find one, what we want to do, we want to return 401 status with a message saying authentication is required. And now back to the Auth controller again, we covered login method and we covered get session. Now the only remaining method to cover is the logout method, and we will see here that we are getting the authentication object from the security context holder, and then we are using this logout handler to initiate the logout. Again, this is something that I found on the Spring Securities documentation, which you can easily find yourself as well and learn more about it if you want so. So if we start the application now, it should work fine, and then we will go to Postman and try to test these new endpoints. Now back in Postman, you see that I created this new request for login, logout and get session. So we will start with login. I'm here using credentials that I used previously to create a user, and if we click send, we will see that it was okay. So this seemingly worked fine, but how do we actually know that it worked fine is by using the get session. So now, because the login request received a cookie in the response, we can just call the next endpoint and it will include the cookie in the request. So if we would send this request, we will see that the session actually existed on the server and it was able to connect the session with the user, and then we get the user response. Now if we go to the logout endpoint and we send this request, it again worked fine seemingly, but we can also check that it actually worked fine by calling the get session endpoint again. So if we do this, now we will get 403 forbidden. Now this is not exactly what we want. So let's now try to make some sense of why the 403 is being returned here. So for example, if we take a look at this line here, we see that there is some log saying pre-authenticated entry point called rejecting access, but we don't really know how did it come to this. So one thing that we can always do is we can find this class. You can use Command P to find any class that you want and click into it. Then you will see this method that is exactly containing the log that we see here in the logs, and you can just put a breakpoint in there. So if we do that and we start the application with debug mode and then we send the same request again. So we are trying to invoke the endpoint which requires authentication. So if we click send, we will see that the debugger will stop at this breakpoint. And now this still doesn't tell us much, but what you can do is to take a look at the stack here, and you will see that this commence method was invoked from the exception translation filter. And this is basically using the authentication endpoint, which in our case is the HTTP 403 forbidden entry point, and it's calling this commence method, which is going to just send an error response with 403 status and access denied message. And so from this we can maybe now make some conclusions what is happening. The authentication is required, but we don't have the authentication, so this exception is thrown, which is saying that the full authentication is required to access this resource. Then the exception translation filter is using the default authentication entry point, which basically just defines what should happen when an authentication is required, but we don't provide one. But because our application will only serve as an API, I think the most reasonable authentication entry point would be just sending a 401 response with some generic message. So what we will do next, we will add our own implementation of the authentication entry point. And this is one of the ways to do it. We will not just be hard coding the response to be 401. We will be checking the accept header. So if the client is going to expect JSON response, then we will be sending just a status 401. Otherwise, we will be using the login page URL, and we will be sending a redirect to that login page URL. This is a new property that we added to application properties, and it is mapping to a property which we also defined here, which is just going to be our base URL followed by /auth/login. But there is one caveat to this, and that is we are using our base URL as our backend URL. And once we start working on the frontend as well, in development at least, you would usually start the server that is serving your frontend code on a different port. And so this wouldn't work, because in our case the login form would be served by the frontend, and it would be, for example, running on port 3000. So here we would then have to have a different base URL which would be used for frontend, but this is then not very compatible with the way you would usually deploy your application, because there you would have everything on the same domain. So for that reason, in one of the following sections we will also be implementing Caddy in local development, so that we can have everything running on the same server, and this closely replicates what you would usually have on your production environments as well. But with that, if we now start the application again and we try to call this endpoint while we are not authenticated, we should no longer see 403, but instead we will see 401 unauthorized, and this is exactly what we expect. Okay, now that we have handled authentication, the next step that we want to take is to handle verification of users' emails. If you remember, what we implemented previously is that when you create a user, we also send out an email to that user, and that contains a link to verify their email address, but we never really implemented the endpoint where that link leads. So here in users controller you see that I added this new mapping, so that will be a new endpoint now on path/api/users/verify email. But you will also see that I made a change here as well, because previously we had /auth/verify email and now we have /users, because I think it makes more sense that we do this as a part of users controller instead of auth controller. So that's one part. You will notice here that this is actually returning a redirect view, and we are going to be redirecting to login page URL, which we already talked about previously. It is currently not properly implemented, and it will be redirecting to actual backend port, and the URL that we are going to redirect to doesn't really yet exist. But for now we will just keep it like that. Let's take a look at the user service. Here we are just trying to find the verification code by the code that was provided in that link, and if we are able to find the code, then we can also get the user because we have that relationship, and then we can just set the verified flag on the user to true. We then also save the user and we delete the verification code. And you can imagine that find by code is just a very simple query where we are trying to find the verification code based on the code that was provided here. So once that all was set, we also have to make a small change in our security configuration, because we want to allow all requests to the verify email. If we didn't add this, it would mean that we require authentication for requests coming to this endpoint, which would make no sense. That's all we have to do here, but there is actually one more change in the user entity. We added a setter here so we can update this field, but I also added this comment here because maybe you will want to implement it based on the comments that I left, but I actually prefer not to, because I want to allow my users to log in to the system regardless of if they verified their email or not. If you want to not allow the user to log in before verifying their email, you will just change this from true to verified like this. And okay, with that we are ready to test this. We will start the application and then we will go to Postman and try to create a new user. So we will just use this new user email. We will send a request. Now when we go back to MailPit, we should see that the new email was sent and we have this verify email link. Now when we click this verify email, we will be redirected to a backend endpoint which we just created. It will handle the user verification and then it will redirect us again back to login page URL, which is currently still on port 8080, but this is where our Spring Boot Tomcat server is running and we don't have that endpoint implemented, so we should just get some kind of an error. But we will soon implement Caddy and this request will be handled properly. It will be sent to the frontend server and not the backend. So now let's try this. If we click verify email, we see that we actually have a bug. So let's go back and fix the bug. So the bug here was that we named this parameter code when we actually expect it to be token. So I just renamed this to token, and now if we restart the application, it should start up fine and we will test it again. We'll just go back to that email again and click verify email. So now you can see that we were actually redirected to /auth/login. But to really check if the verification was successful, we will have to take a look at the database directly. So let's just refresh this. We see a new user here with user1 email, and we see that the verified flag was set to true. The next thing that we want to implement is the forgot password flow, and you can see that I have already made the code changes for that. But let me just give you first a high-level overview of how that flow will work. You can imagine that the user will be able to see some forgot password link on the front end, and once the user clicks on that link, he will be presented with a form where he can input the email address, and then there will be some button that will send the request to the backend, and basically that request will be received here in the forgot password endpoint, which will just try to find the user based on the provided email, and it will send password reset token in the email to this user. So once the user clicks on this link, he will be again redirected to the front end on some page where he can input the new password, but that page will also read the token from the URL, and it will forward that together with the new password to the next request, which we haven't yet implemented, but we will do that next. So let's now quickly go over the changes here. I already mentioned we added this new endpoint called forgot password, and we can see that it's part of the user's controller. Now this is a post endpoint, and it's expecting a email in the request body, which also has to be a valid email. Now, because this is a new endpoint and we want to allow access to this endpoint to anyone, not just authenticated users, we also had to add this new line here where we just specify that we want to permit access to this endpoint. So what this method does is just calling this forgot password function inside the user service, and here what I already explained, we are going to first try to find the user by the email that was provided, and of course in case we do not find the user, we don't want to continue, so we will just be throwing an exception. This API exception was mentioned before. It will be just translated nicely into some HTTP error response. Once we found the user, then we can create a password reset token, and this is a new entity that we created. It only holds some token email sent flag, but it also holds an expires at flag, and it has a relationship to the user. Here we also have some methods like isExpired, which we will use in the request where we want to update the password. We will first check if the password reset token has expired. And we also have this on email sent method here, which should be invoked once the password reset token has been sent in the email. And we just want to set the email sent flag to true, and we want to update the expires at to 10 minutes in the future. So once we created the password reset token, of course we want to persist it. And what we do next, we are going to send out this email. For that we created the new job here in jobs, and if we take a look at that, we'll see that it just contains a token ID, and it defines the handler, which is going to be send reset password email job handler. And this job handler is also very similar to this send welcome email job handler. It will just try to find the password reset token, and if the email was not sent for that password reset token, then we will invoke this method send reset password email, and inside we will just create a link which will link to this page where the user will be able to input a new password. And for that we have also a template that will expect a link and user variables. So we are just using here a template engine to process this new template, which is going to be this one. So here we are just saying that the password reset was requested, and we have a link below to reset the password. Okay, once we have the HTML body, we are going to be using the email service send HTML message to actually send this email. If this was successful, we want to invoke this on email sent method, which will set the email sent flag to true and update the expires at. So now we should be able to test this, but as you can see on the screen, I already tested it and it failed. But if we take a look at the application here, we will see this log, and it basically is coming from this relationship here because it's one-to-one. And this is actually a mistake. What we want to do, we want to make this many-to-one because we want to allow the user to request password reset multiple times. Because, for example, what might happen is that email won't be sent and we already created password verification token, or for example, user will not be able to finish the flow for some reason in 10 minutes, and then we will not delete the previous token, and the user will also not be able to create a new one. So this is definitely a mistake, and once we fix this, we should be able to rerun the application and we will try again. So after sending the request again, we will see that it will fail again. But the reason this time is that because we have this hibernate DDL auto set to update, it will not actually properly update the constraint, so we have to go manually into the database and remove the constraint. So one of the ways to fix this is that you open your password reset token directly in the database, and if you go here to constraints, you should be able to see some unique constraint. I don't see it now because I deleted it, but basically the way you want to delete it is you will first want to delete the foreign key, and after you delete the foreign key you can persist the change, then you can go to constraint and also delete the constraint, and after that if you just restart your application, JPA will recreate the foreign key but this time without the constraint. And so with that, if we restart the application again and we send this request, we should see that now it is successful. And if we go back here in MailPit, we will see in a second that the email should be sent, yes. And this email contains a password reset link, which is exactly what we expect. Okay, now let's implement the next part of the flow. So once the user receives the email and he clicks on that link, he will be presented with a form where he will send a new password together with the password reset token to this endpoint here. So this endpoint was added to the user's controller and it is on the path /reset password. So we can see that it is a patch mapping and that it's expecting this request to contain a new password, also has to be valid, and password confirmation, which also uses this custom validation that we built in one of the first sections, and it also expects this password reset token. So if we go further in the user service reset password, we will see that we are first going to try to find this password reset token from the database using this find by token query. Then if we are not able to find the password reset token, of course we will not continue, instead we will just throw an exception. But in case we do find it, we will first also check if the password reset token is expired, in which case we will also throw an exception. But otherwise we will get the user from the password reset token and we will call this update password method on the user entity, which is just going to use the password encoder to encode the newly provided value for the password. And after that we will just save the user entity. And that's pretty much all the changes that we did, except for this one. We also had to add permittal for this endpoint because we also do not expect the user to be logged in when he requests the password reset. And with that we should be able to test this. So you see here that I created this new request for resetting the password, but we have to first start by initializing this flow. So we will first request a password reset token, which will be sent to email, and the email should be sent here in a second. After that we will just see what the token is. In the left bottom corner you see that it's 326086, so we will use that here in the reset password, 326086, and we will just change the password to be, instead of the old password which was just password, we added this S. So if we send this request now, it should be response status of 200. But to actually make sure it works, we will go to login and we will try this new password, and of course we have to use the same email. So if we click send, we will see that it's also successful. But to also make sure that this is correct, we will invoke the get session, and we see that indeed we are getting this session for this user with this email. Now let's go on and finish the implementation of the user's controller. So the only two remaining methods that we currently want to add is the method for updating basic user details and method for updating the user password. But this method for updating the password is different from the one that we implemented previously, in a sense that this one will be only allowed to users who are already authenticated. So you can imagine that the user will be able to log into some kind of a dashboard, and then there will be some section that will allow the user to change their password. And how it's done, usually you would have to provide your old password together with the new password. But let's start with this one first. So you see here that it's a put mapping and it has this path variable which is going to ID. It's not actually used anywhere, but this is just to follow some kind of a convention. We are expecting a update user request, which is just going to take in a first name and last name, and we are going to forward that to the user service update method. And if we take a look at that, it's going to get the currently authenticated user and then it's just going to initialize the user reference, and then we are going to invoke the update method on the user entity, which is going to set the new values for the first name and last name. Currently there is not much data on this entity and we only have these two variables to update, but you can imagine later on you might be adding more stuff, and then you might have a different method for updating other properties, but you might also use this one. So after we've done the update, we will just save the new user details and return the response. So going back to users controller, let's now cover the other method, which is going to be for updating user password. Here we see that we are expecting this update user password request, which is the same data class that we expected for resetting the password, but we just added this new field called old password, and then we are invoking the user service update password with the request data, and we are going to do something similar. We are going to first get the authenticated user, and then we are going to check if the user password is not null and the password and the old password that was provided in the request does not match the current user password. In that case, we are going to throw an exception saying that the user provided a wrong password. Otherwise, we are going to invoke this update password method, and that is the same method we used for resetting the password. It will just take in the new password value, encode it, and set the encoded value to this field here. After that, we will just save the user data and return the response. So that's pretty much it. We didn't have to make any changes to security configuration because, as I said previously, we want both of these endpoints to be only allowed to authenticated users. Let's also just make this transactional because I forgot that. So now if we start the application, we should be able to test this. And here you can see that I've created these two new requests in Postman. First one is for updating the basic user data, which if we invoke it now, we should get unauthorized, which is exactly what we expect. But if we go back to the login request and first do a login, and then we go back to update, now the cookie will be sent together with the request and we should be able to get a successful response. And you also see that the first name and last name were updated. Now we will do something similar with the update password, except this time we don't have to re-log in because we already logged in. So here we see that I'm using the old password, which is the correct password, and we are using the new password with this confirm password field as well. So if we send this request, we should see that it was successful, and if we try to log in with the new password, we should also be able to do so. So if we go to login request and we use a new password, we see that we logged in successfully. Okay, so next thing that we want to implement is Caddy server. We mentioned this a couple of times before when we were doing redirects to the front end, but our current base URL is not actually our base URL because it is our backend URL, and we will also have a different server which will be serving our front-end code. So for that reason, we want to have some kind of a reverse proxy that will be deciding which requests are meant to the backend and which requests are meant for the frontend. And then our base URL will be actual base URL because it will be pointing to this reverse proxy and not to backend or frontend servers. And the reason we will be using Caddy is because I think it's the best option out there. You might be familiar, for example, with Traffic or Nginx as some other options. But I think Caddy is very simple and also very powerful. So let's now take a look at the changes that we had to make in order for this to work. First, we had to add this Caddy file, which is going to be placed in our Infra directory. And it is just a simple configuration file that is specific to Caddy. And what this configuration file is actually doing is just going to specify that we want to proxy any requests that are starting with /API to our localhost 8081, which is the port where our backend will be running. But for that, we also had to make this change in our application properties files to make sure that our server will be served on port 8081. These other two lines are going to be specific to Oauth2 login flow because Spring Security by default uses these paths for authorization and code endpoints during the Oauth2 flow. So what we are saying here is that if we receive any request to Auth2 / authorization / anything else, we still want to forward that to our backend. So the only difference here is that we are missing the /API. And then for any other request, we want to forward that to our localhost 3000, which is where our frontend code will be served. There's one more thing that we had to do here, and that is to add this Caddy container to Docker Compose file. And now if you run Docker Compose up and let the Caddy container start up, you should be able to test that this works properly. But before that, you should also restart your backend application so it can start on a proper port, which is going to be 8081 now. But if we go back to our Postman, we should see that we don't have to make any changes to our paths here. We will still be aiming for port 8080, but this request will just be properly forwarded to the backend. So just to prove this, if we send this request, we will see that it still works as expected. Okay, so we are coming close to finishing off the backend implementation, and there are basically two things left to do. One is the S3 file uploads, and the other one is login using GitHub or Google. But in order for us to work on the login, we will first implement some basic pages on the front end, which will help us test that easier. So for that reason, now we are going to cover the implementation of S3 integration. And here we will start with this new class, which is going to be called S3 configuration. We see here that it is a configuration properties class, which is going to use the app.s3 prefix. And we see here some properties like bucket name, region, access key, and so on. We will need these properties to generate our S3 client, for which we are going to use AWS S3 SDK. And we can now actually see that inside here in file upload service, which is also a new class that we added. Here we will have some S3 client property inside the class, which we will create inside this constructor. So we are injecting the configuration properties, and then we are creating this S3 client using those configuration properties. Besides that, we have this upload file method, which is going to take a file path, and that is just basically the folder structure at which we want the file to be, and it will take the file itself. So what we are doing here, we are going to just create this put object request using the S3 SDK, and then we will use this put object method, which is going to invoke the request to the S3 and actually save the file there. Because we want this method to return string, which is going to be the URL of the object that we just uploaded, we also have to do this, and that will basically just get the file that we just uploaded using the same file path that we defined before, and we will get its URL, which we will return to the caller of this method. But you might see here that we also added this uploaded file, which is just an entity, and it will represent all the files that are uploaded to S3. It holds some properties like URL, size, original name, extension, created at and uploaded at, and as well as relationship to the user. So the relationship is many to one, which means that one user can have many files. Besides these properties, we see that we have a constructor and two methods, and how this is supposed to work, we should create an uploaded file entity even before we actually upload the file. And after the file is uploaded, we would then invoke this method, which would update the URL and the uploaded at property to current time. This build path method will be used to, well, build the path at which the file should be located. And you see here that we are going to use the user : user ID as the root directory, and this is so we can split the files based on who they belong to. After that, anything that we pass in here will be used to build the rest of the path, and in the end we are going to assign a random UUID as the file name, and we will use the original extension. But you might already realize that we currently do not have any way to test this, so for that reason we also added a new property to our user entity, which is going to be this profile image URL, and then we also added a new endpoint which is going to be used for updating the user's profile image. So here we see that we are going to take in a multipart file, and we are going to invoke the user service update profile picture. If we take a look at that, we will see that here we are first going to try to get the currently authenticated user, and after that we are going to create a new instance of uploaded file. This is what I was talking about previously. We are creating an instance of uploaded file even before the file was actually uploaded. So we are going to pass the original file name, file size, and the user. So the next thing that we want to do, we want to use the file upload service upload file method that we just showed. And for the first parameter here, file path, we are going to use this build path method that we also just looked at. And then additionally, we are going to also add in a folder that is going to be called profile picture. So you can imagine that for a user with ID 6, our file will be at some path that will be user:6/profile picture/some random UUID.file extension. And so once the file was uploaded, we should be on this line, and we will invoke the onUploaded, which will update the URL on the uploaded file entity. And after that, we also want to set the profile image URL on the user entity. In the end, we will just return the user response, but we also added this new property profile image URL to the user response. So we could now open Postman and test it, but I think I haven't shown the application properties. Here you see the different properties that we added. They are basically those properties appended by app.s3. So we have bucket name. This is something that you will have to create on your S3 provider. For example, if you use AVS S3, I don't know how you do it there, but this should be pretty easy. You can probably use CLI or their UI. But as you see here, I'm using s3.tebi.io, and I would recommend you to do the same. It's quite a lot cheaper than AVS, and their UI is much better. Also, don't waste time trying to use these credentials, because I will remove them as soon as I finish recording. And with that, let's actually try to test this. Here you see that I added this new request to Postman. So if I go here to get session, you'll see that I'm currently not authenticated, but if I first log in with this email and password, I should see that my ID is 6. And you already see that I have a profile image set because I tested this before, but we will now update it. So let's go back to update profile picture. So you will want to use the ID of your currently authenticated user, and here in the body form data you will specify a file. This key here has to match what you specified in the controller here. If we now send this request, we will see that it takes a while, but it should finish, and we will see that we get a successful response. And now that we have created most of the stuff on our backend, it's time to start working on the front end. Here you see the page that I already implemented. And here on the screen you see some, and you might remember that, we already created our starting project for the front end. But you see on the screen that I also implemented a few more things now to get us started. So we will have this home page with a navbar and this login button, which is going to be a link that leads to Auth login. So let's take a look now at our front-end code and explain the changes that we made here. To get started, you will first want to install some libraries that we are going to use, but it's basically just shadcn. For that, you will want to go to shadcn website. You will click here on the installation and you will follow the guide for nextjs. Basically, you want to skip this because you already have a project, and then you will just use this shadcn UI latest init command, which will give you these prompts, and then you can follow the rest of the tutorial, so we won't spend too much time on that. Let's go back to our code. Most of these will be added automatically by shadcn, as well as this tailwind config class, and some of the changes will be made in the global CSS file. Also, this components folder will be created with a UI subfolder. In this UI subfolder you will have all your shadcn components, and all the rest of these components that are directly in the components folder are the components that I created, and we will cover those in this section. Here you see the changes that we made, and most of this was done following the guides from shadcn. So during the installation guide you will set up this font sans here that you will reuse in the body class name, and for the theme provider you will want to go to shadcn and you can just search for dark mode. And if you follow the instructions on this page, you will basically see here that this is exactly the change that we made as well. So this will just allow us to use the theme changer so we can switch between the dark and the light mode. Now this is not the only part that makes this possible. We also had to make this mode toggle component, but this part is also covered on that page that we just showed. And now let's just also take a look at the navbar. This is also a new component that was created here in the components folder, and this is basically here the top part, which contains our logo, mode toggle, and the login button. It's using this container, and this is basically just a helper component that will help us center the content horizontally and set a max width. Then inside this container we have a logo on the left side, and on the right side we have this mode toggle and login buttons. The logo is placed here in the public images folder, and it is just some random logo that I downloaded from Canva. Other than that, you see I created this Auth folder, and inside we have forgot password, login, register, and reset password pages. All these are currently empty, but that is going to be one of the things that we are going to implement next. And then we also have this profile page, again with an empty page.tsx file, and this is going to be our authenticated user profile, from where we will be able to use most of these endpoints that we created for the user to update our basic data, to reset our password and stuff like that. Okay, so moving on, we will be implementing authentication related pages, and the first one that we are going to start with will be the register page. Let's now take a look at the code changes. So if we come here, we will see that the changes were made in the page.tsx file in the register directory. And as I stated previously, I am not spending the time to type this in the video live or even explaining this because I don't want to waste anyone's time. You can always pause the video if you want. You can also go to the GitHub repository and just copy the code. So with that said, there isn't really much to explain for this page. We have some basic markup that is going to be centered, and we have this user register form, which is going to be a also new component that we created, and here there is some things to explain. First, we are going to be using Zod for schema validation, and here we see that we define some schema that is going to be used for our user registration endpoint. Now going down further, we see that we have some state like is loading, success, and error or errors, and this errors is going to be of type HTTP error response. This is the same type that we have defined on our backend. In our global exception handler, we are going to be constructing this type of object and be returning that as the error response from the backend. So this will allow us to handle the errors in a unified way on the front end as well, and you will see that in a second. So let's go back to the register form. We also have this onSubmit method. This will of course be invoked when we click the submit button or create button or whatever the button is. And first we will reset all the state, then we will use HTTP client to send a post request to our API endpoint together with the data. And in case the request was successful, we are going to use this toast, which is going to come from the Sonar. This is something that comes from shadcn, so you will have to go to shadcn, search for Sonar, and just follow the instructions to install it. And also we set the success flag to true. If it fails, we are going to get the data of the error response, and we are going to cast that to the HTTP error response. It is safe to assume at this point that this is going to be of this type, so we cannot really go wrong. And then what we are going to do, we are going to also update the errors state on the component here. And finally, we are going to set the loading to false. We are also going to be using this use form. It is another library that we added. And if you take a look here, you will see that it's coming from React Hook form. So you will have to also install this npm I React Hook form, or just search for it on Google and find it on npm. And then follow the instructions to install it. And inside this use form function, we are going to pass in a resolver, which is going to be a Zod resolver, since we are using Zod to validate our schema. And we will define this revalidate mode on submit. So this means that we do not want to trigger validation of the fields before we trigger the submit. And so for this markup, I will just explain this part, which is another component that we made, and basically it has 4 properties. Show, which is going to control if the component will be shown or not. The message is going to be a message that should be shown in case we have some successful action. A description and an action, where an action is just a React node. In this case, we are going to be putting in a link. So what this will allow us is that wherever we have some kind of an API request and we want to show some message if the request was successful, we can use this success feedback component. So you will see what this looks like once we start testing our register page. But below that we have this form element which is going to have the handle submit method. This is coming from the use form. Handle submit will just basically prevent the default of the event. Then it will probably trigger some validation, and in case it was successful it will invoke this onSubmit method. This is the method that we shown before. We can also pass another method here as the second argument, which would be the method that will be called if the validation fails, but we are not doing that here. So below that we just have some fields like email, password, confirm password, first name and last name, and in the end we see a new component, error feedback, and a button that is going to say register. So the error feedback is also a new component that we created, and the purpose is similar to the success feedback. So basically we will use this wherever we have some kind of a form and we are invoking some kind of an API request, and if the request was not successful and we have some error response, we are going to be displaying that error response in some nice looking way. So you see here that we are just going to pass in the errors, which is the state that we showed before, but the error feedback itself inside will be checking if the errors is not undefined. So if we just pass in undefined here or null, nothing will be shown. So this component not just helps us to display the errors, it also helps us in a way that we do not have to conditionally check in each component, do we have the errors or do we not have the errors, and then show if we do or not if we not. And if we take a look at the markup further, we are going to see that we are checking each of the properties of the HTTP error response. So if we have a message, then we will show a message. Then we check if we have errors, and if we do, we will show them as well. If you remember, the errors are actually going to be field validation errors. And then we also have general errors, which basically can be anything, but they can also represent and will mostly represent the errors that are object specific and not field specific. And that's it for the register page. Now let's see, did we miss anything? Yeah, we haven't looked at the HTTP client. I will be using Axios, and what we are doing here, we are just creating this HTTP client variable, which is going to use Axios to create a new instance, and we are going to pass a base URL, which is going to come from our environment variable. So we'll take a look at that in a second. And we have some additional properties here, and in the end we are going to export this HTTP client. And what's left now is to take a look at the environment variables, and for now we just have this next public base URL, which is going to be a URL to our reverse proxy. Now to test this you will have to run the application, so npm run dev, and then you will go to localhost 8080/auth/register, and you should see a page like this. And as you can see here, we have a login button at the bottom as well, which is a link to the login page, and we have two additional links to terms of service and privacy policy. These do not yet exist, but we will create them in one of the probably latest sections. So now I filled out the form, but I think we should be getting a validation error on the backend, so we will have some kind of an error response, and we will see how the error response will be shown here on the page. So if I click register, and you see that we get this unprocessable entity message with two fields being wrong. So first, the password must contain at least one uppercase letter, one lowercase letter, and one digit. And for the email, it says user with this email already exists. So that's really nice. And I just wanted to show you what it looks like. Now I will fix the issues, and if I click register again, oh, this isn't an email, so that's also good. You see that the submit button or the submit method was not actually invoked because the validation failed. And now if I fix this as well, and if we click register, we will see that the account was created, and this is the success feedback that I was showing before. And here you also see we have this login button, which will just going to take us to the login page, which we haven't yet implemented. So here you see that we got an email to actually verify our email address, and if we click this link, you remember that we will be redirected to a backend endpoint, which will verify our account, and then it will redirect us back to the login page. But since we do not yet have the login page, I think it makes the most sense now to implement that next. So here we are on the login page that we just implemented, and you can see it looks very similar to the register page which we shown before. We will soon cover the code for this page, but you also see that here we created this link that we mentioned previously that will lead to the register page. And this means that now we have a way to get to this page without typing in the path in the URL manually. So let's go back now to the login page. Currently it only supports email password type of login, but we will soon add the buttons here that will be used to log in with GitHub and Google. So let's now take a look at the code. So we will start here from the login page. Now this is a very similar markup to the register page, and again we are not going to explain it in details. We also see that we have this user auth form similar to what we do on the register page, and this form is also similar to the register form. We are going to define our schema, which is only going to require email and password. Then we have some state for loading, and we have this use auth guard which we added, and we will cover that in a second, but here it's only returning us this login method. Then we have this onSubmit, which is going to be invoked by the form here, and the onSubmit will invoke the login method that we get from the guard. And similar to the register form, we also have this error feedback component, which is going to show any API errors that occur during the login process. Put simply, the purpose of this hook is to get us the authenticated user data. So we see here that it will be invoking the API/auth/me endpoint, which is going to do exactly that. It's going to get the currently logged in user session data, and then depending on these properties that we pass, different things might happen, and we will take a look at that in a second. But we also see here that we are defining this login method, which is going to take in this onError callback method, which is going to be invoked if during the login process we have some error that happens on the API. And we also take in some props which are going to be used here to send the login request. We are going to use the email and password from these props to construct the data for the login. So this login method combined with this data here. So you might notice here that we are using this use SVR, which is a library that you might be familiar with, and by the way you will have to install this by saying npm install SVR. Use SVR is really helping us here by caching the response. And what do I mean by that is that imagine you have two components that are nested one inside another, and you would be using this hook inside both of them. Now if you weren't using use SVR here and you were just sending a request manually, what would happen if you load some page that has those two components inside? The request would be sent twice. And because we are using use SVR, it won't be sent twice, because the first time it was sent, the use SVR will internally cache it and it will not send it again. If we do want to send this request again, we can use this mutate function, and that's exactly what we are using here in the login method, because once we logged in, we want to try to send this request again to get the session data, because we now expect that we will have the session data because we just logged in. Now let's check what else do we have here. We have this logout method, which is first going to check if we do not have an error, which means we have the data and we are authenticated. In that case, if we want to log out, we invoke this method and it will invoke the logout endpoint. And if that was successful, we also want to call the mutate because we want to update the state, because now we no longer have the session, so we want to tell SVR, hey, go fetch the session again, and then it will realize we do not have the session. After that, we will just be redirected to the login page. And then we have this use effect here that is going to be called when either user or error changes. So basically we can have user if the request to get session was successful, and we will have error if the request to get the session was not successful. I think it's best if we just go back to that login form, and you will realize why we have this if statement. So you see here that we are defining the use auth guard with a guest middleware, and we are saying that we should be redirected to the /profile page in case we are authenticated. And now for this scenario, you can see that it's quite simple to understand. We have a login page which we can access as a guest user, so we don't have to be authenticated if we want to visit the login page, which makes sense. But if we are authenticated, then we want to redirect to the profile page. Now this property is optional, and if you just leave it out, you can also visit login page if you are authenticated. And the other check we have in here is that if we require authentication, which means we are using the Auth middleware, and we have an error, which means we don't have the session, then we are going to invoke this logout function, which is going to skip this part because we have an error, and we are going to be redirected to the login page. And we skipped this part here, and that is we are expecting the response data to be with this user response type, and this is basically the equivalent user response type that we defined on our backend as well. So you see here we have an ID, roles, which should be role, this was a mistake. We have first name, last name, email, and profile picture URL. Just before we test the changes on the front end, I want to show one more change that I made on the backend. You see that we added new exception handler for bad credentials exception, and that is because this exception is thrown by Spring Security in case the bad credentials were provided during login. We want to handle it because we don't want to show unexpected error on the login page once the user didn't provide correct credentials. Instead, what we want to show bad credentials message. And we actually made another change in the front end here that I forgot to mention. In the navbar component, now we are also using the auth guard, but this time with the guest middleware, because we are not going to require the user information in this component. But what we are doing here is that we are going to show some kind of a user nav, which is just going to be a drop down in case we do have a user, and in case we do not have the user, we will be showing the login button. So if we take a look at the user now, you will see that it's a drop down menu component that's coming from shadcn, so you will have to go to shadcn and find this component and install it. And this drop down menu component is quite simple. It's just gonna show the user email and two links below. One is going to be for the profile page and the other is going to be the logout. So with that, I think we can go to our login page and test this. So I have created this new user with this email, and we are going to provide some wrong password, and let's see what happens. This is an invalid email, so we'll try again. And now you see what I was talking about. If we haven't made the change on the backend, we would be getting the unexpected error here, but now we are getting the bad credentials. So let's provide the correct credentials this time, and let's click login again. And you see we are redirected to the profile page, which is just going to say here welcome back, and it's going to use our username. And we also see that the navbar changed. Now we no longer see the login button. Instead we see this drop down with a profile link and a logout. So if we try to manually go back to the login page, we should be redirected back to profile, which is exactly what happens. Now if we try to log out, we should be redirected back to the login page. Now that we have implemented login page, we can now finally test this verify email functionality that we were not able to do before. So when I click this link here, it will redirect us to the backend, where backend will verify our account, and then we should be redirected back to the login page. So let's try this. If I click here, you can see that it looks like we were instantly redirected to the login page, but if we go to the database and we refresh this, we will see that this user was actually verified. Okay, so let's now implement the remaining authentication related pages, which are going to be this page, from where we will request our password reset token, which should arrive to the email address that we specify here. The first page that we have just seen is going to be this forgot password page. And this is very similar to the login and register pages. We are just using the password schema with email property. The implementation of this component is very similar to the components that we have seen previously, so we won't be going into details. We'll just say that this onSubmit method is going to send a post request to forgot password endpoint, which will send an email to the email that we specified in the form. And once we click on that email, we will be redirected to this page here. But let's now just quickly scroll through this component, and you will see that it's pretty much the same like the components that we saw previously. So now let's take a look at the reset password component. Now this is a page that we will use to set our new password. It's going to be using this reset password form. And again, this is very similar to login and register and the previous component. So here we will be sending a password, confirm password and password reset token to the backend. And this password reset token will be taken from the query parameters. And if we take a look at the rest of the component, we will see that it's pretty much the same as login and register and forgot password components. If we go back to this forgot password page and we use the email of the user that we previously created, this one, and we now click send reset email, an email should be sent to this user. We will just wait a couple of seconds here in Mailpit. And here it is. So if we click inside, you will see that we have this link which will go to the reset password page. Let's click it. And now let's specify our new password and click update password. And it was successful. So if we go back to the login page, we use the same email and we use the new password and click sign in, we should be able to log in successfully. And the only thing now left to implement to wrap up our authentication page is going to be login with GitHub or Google. And for that we will need to make changes on both our frontend and the backend. So we will start by looking at the code changes that we made here on the backend. And you will see that we added this change to the security configuration class. And what we are saying here is that once the Oauth2 authentication flow is successfully finished, this success handler will be invoked. But here we are providing our own success handler. We will take a look at the implementation of this success handler in a second, but maybe a better place to get started would be these application properties changes that we made. So basically the only thing that we have to provide in order to have this whole authentication Oauth2 flow working is these properties. So for each of the providers that are supported by Spring Security, we will just need to provide the client ID and the client secret, and Spring Security will do the rest for us. So here, for example, you see that I provided the client ID and the client secret for GitHub. I will show you in a second how you can get those. But for Google, you would basically do the same. In my case, I just provided some dummy values. These are not actual secret and ID. And then one more thing that we added here is the login success URL, which is going to be the URL to which we are going to redirect the user. This was also added to the application properties class, which is our configuration properties that is going to map the properties based on the app prefix. So now let's take a look at the success handler that we saw previously in the security configuration class. So this will be invoked once the Oauth2 authentication flow is successfully finished. And now at this point, Spring Security has user details that are coming directly from the provider for which the flow was initialized. So inside this class, we can see that it's a component and it's also implementing the authentication success handler. And for that, we have to override this method, which is going to take the HTTP request response and this authentication object, but the authentication object will be actually of type Oauth2 authentication token. This is also a class that is coming from the security Oauth2 client package, which, if you remember, we added in the first section. So from this authentication token, what we want to do, we want to extract some properties. First one is going to be the provider. So this will be either GitHub or Google. And provider ID, this will be your username on that provider. So if your username on Google is going to be Nermin, for example, this provider ID is also going to be Nermin. And then we are also going to try to extract the email from the attributes. So because we have two different providers that the user can use, what can happen is that the user can log in with both of them. So maybe one day you want to log in into the application using GitHub and the other day you want to log in using Google. So we need to keep track of which user is connected to which account. And for that we have to create a new entity and a relationship with the user. And this will be our user connected account entity. If we take a look at that, it's gonna be a simple entity that is just going to hold the provider ID and the connected at values. And we'll also have this relationship to the user. So first we are going to try to find the user based on the connected account, and we will look up this connected account based on the provider and the provided ID that we extracted previously. So we are going to invoke the method here on the connected account repository called find by provider and provider ID. And if that is going to return some value, then we are going to call this authenticate user method, and we are going to pass the user that is connected to this connected account. So if we take a look at the authenticate user, that is just going to create a new authentication token, which is going to be authenticated. And then we are going to set this authentication to the security context holder, and we are going to issue a redirect to the login success URL. So this is the case when we have successfully found the user connected account. But if we continue further, we will see that this comment here explains what happens next. So at this point we do not have a connected account, so we either find a user by email and add the connected account to that user, or we create a new user, in which case we will also have to create a new user connected account as well. So that is going to happen in here, but in both cases we are going to call this authenticate user, which is going to do what we previously already explained. So either way, in this method we are going to end up with a new authenticated user in our security context holder, and we will be redirected to the login success URL. Now let's take a look at the changes that we made on the front end. First, in the login page user Auth form, we added these two links that are going to be used for Github and Google login. And for the href property, we are going to be using this get provider login URL function, which is going to take in a provider as an argument. It can be Google, Facebook, GitHub, or Okta. These are all providers that are going to be supported by default by Spring Security Oauth2 client. So what we are doing here, we are just gonna return this URL, which is going to use our base URL and then /Oauth2 /authorization the provider name. And that's it, but we also created this login success page. So on this page, we will just be letting the user know that the login was successful and that the redirect will happen in a few seconds. So with that, if we now start the backend application and also the frontend application, we should be able to test this. So going back here to the login page, we see these two new buttons, and now if we click the GitHub link, we are redirected to this page on GitHub, and if we click authorize, we are then redirected back to our login success URL. But for some reason this isn't counting down, so we'll have to fix that. But for now, let's click this take me home, which is going to redirect us to the home page. But we also see that we are indeed logged in, so we can also visit our profile page. And here we see that we do not have the user's first name, which should be shown here after the comma. But that is basically because I already created this user before, as you can see here in the database. And you also see that I have a password, so you know that I actually created the user. But when I created the user, I didn't set the first name or the last name. We will actually try to extract this data from the user details that we receive from GitHub. So in case we didn't have this user already in the database, it is possible that we would have successfully extracted the first name and last name, but it is also possible that we wouldn't. So if I haven't done this before, we would have tried to extract the first name and last name from the user details that we receive from GitHub. But if we take a look at the code here, when we are trying to create a new instance of the user, we are going to assume that the first name and last name will be part of the name attribute, which we are getting here. And then we are going to try to split this name based on the empty space. And we're just gonna get the first parameter after the splitting, which is assumably going to be our first name, and the second parameter or the second value in the array should be the last name. So yeah, this does seem a bit fragile and maybe could be improved upon, but this is the implementation that we currently have. So now that this is working, I think the next part that we are going to implement is this profile page. So on this page we want to show the user's details, and we want to also allow the user to update those details. So things like first name and last name will be updatable, also the profile image and the password, but we will not be able to change the email. So this is the page that we are going to work on now. Here you see that we have a few sections. First section is going to be used for the logo. This is a clickable avatar which we can use to update our profile image. Then we have another section here for updating our basic user details such as first name and last name. Below that we have a section for updating our password, and after that in the end we have these connected accounts, which is just going to show which accounts are connected to this account. So here you can see that we used GitHub to log into this account. So for now, let's take a look at the code, and in the end we will come back to this page and test all of this. So we will start with the profile page here in the profile directory, And this is a pretty simple markup. You see that we have this first h1 which says welcome back and uses the user's first name. Then we have a few sections here, like the first one is going to be the profile image form, the second one is going to be update basic details form, and the third one is going to be the password form. And also in the end we have this connected accounts section as well. And while we are at this page, you might notice that we also added this change here as well. So basically, because this page we are going to protect using the auth guard, this guard is going to require us to have authenticated user session in order to access this page. But what is going to happen when we navigate, if we didn't already use auth guard previously and we do not have the cached user data, while the request is still going to be running to get the user data, we will not have this user here, so it will be undefined. And for that reason, if we, for example, try to access some properties of the user, we might get some exception because user is currently not defined. And that is the reason we have this if statement here. So we are going to display some loading spinner while we are still fetching the user data. So if we take a look at this loading component, it's just going to show some spinner icon that is going to be centered in the center of the screen. But if we also take a look at these icons, it's coming here from the components. This is a new component that we added, and it's just an object that has this spinner property which is going to return the SVG for the spinner. Now, to clarify this, you will probably not have to do this for every page where you are using the auth guard. So one of the ways we can avoid checking this in every component or on every page where we are using the auth guard is to make this check inside the layout file. Maybe I can show this later on when we will be implementing the admin dashboard. For that we will be creating a separate layout and I can showcase what I mean by this. But let's now go on. So we will check first here the update profile image form. It is a small component that just has this file upload inside. It will be displaying the avatar as a trigger to get the new or select the new image, but it will also use the user's information that we get here from the use auth guard to display the image if the user already has an image. So the file upload component that we are using here is also a custom component that we created, and it has quite a few helpful properties here that we can pass for validation of file type or size or dimensions and stuff like that. But I'm not going to go into details here. Let's now just go back and see how we are actually using it. So we see that we have this onFileSelect callback, which is going to be invoked when the file is selected. And in this case, we are going to be invoking this handle a logo change function, which is going to take in a file, and we are going to create a form data to which we are going to append a file property which is going to contain the file that we received here. Then we are going to invoke a patch request to our profile picture endpoint, which is going to have to be multi-part form data content type. And you might remember that we implemented this before. This is the endpoint that I'm talking about. So once that is successful, we will just show this toast that the profile picture was updated successfully. Because now the user details are also going to change, we want to call the mutate method. We want to invalidate the current session data and we want to get the new one because that will also contain our profile picture. And in case the request fails, we'll just show this generic message. And one more change that I had to do, something that we missed previously, is here in the layout we added this toaster that is coming from the Sonar library. And this is basically needed for the toasts to be working. So we were using them before, but we didn't really notice that they do not work. So that should now hopefully work. We will see that in a second, but let's go back to the page and see which is the next form. It's going to be update basic details. Now this is going to be very similar to the forms that we saw before, like for the user registration, login and stuff like that. So I'm not gonna really spend much time here. We see that we are just going to populate the form with the default values from the user data that we are getting from the use auth guard. Then we are going to have this onSubmit method, which is going to be invoking the endpoint for updating the basic user data. And in case it is successful, we are also going to invoke the mutate method so we can immediately invalidate the cache that is used inside the use auth and get the new user session data. This form is maybe a little bit different than the forms that we have seen previously, but if you go to shed cn and you just search for form here in the search input, or go here in the sidebar and click on the form, you will see that this is exactly the form component that we are using, and it's pretty much based on the usage that is displayed here. Okay, going back to our page, we see that the last form displayed on the page is going to be update password form. And if we take a look at that, we will see that it's very similar to the previous one. So there's no reason to explain anything in details here. And yes, so with that, I think we covered all the changes on the front end, except here in the user response, we also changed this a bit, because it was called profile picture URL and it's actually called profile image URL on the backend, so we fixed that. We also added this new property called connected accounts. This is a change that we also did on the backend. We will take a look at that in a second. But this is just going to be a simple object that is just going to have this provided property and connected at. And one more change that we did is we made the first name and last name optional, because they are also optional on the backend. With that, I think we covered all the changes on the front end. So now let's take a look at the backend. I already mentioned that we added this connected accounts property to our user response. We are going to populate the connected accounts response, which is a record that holds the provider and connected at properties. So we will populate that in the user response constructor by getting the user's connected accounts, and then for each of these accounts we are going to create this account response object, and we will put that in this connected accounts array list. And that's it. Now we can go to the application and start testing. So let's start with the logo. I will just pick some picture that I downloaded from Unsplash. So if we click open, you will see that we get this validation error here saying that this is an invalid type, only PNG and JPG are allowed, and we got JPEG. So this looks like something that we should actually fix, and the way to fix it is that we will add image JPEG in here as well in the allowed types. Let's try again. You can see here that I had downloaded a new image that is going to be smaller than this one. So if we click open, we should see that the profile picture updated successfully. And we also see that the avatar here updated immediately. Now let's go on to the next section and we will try to update our last name. For example, if we click update, we see again the toaster is saying that the profile updated successfully. So let's try now with the password. I'm gonna type in my current password, and the new password is going to be with one additional character at the end. Like that. If we click update password, it also says that it was updated successfully. If I log out, and now if I try to log in using this email and the new password, let's see what happens. You can see that we can log in successfully, and there is nothing to test for the last section here. Okay, so the next thing that we want to implement is the admin users dashboard. But we currently do not have any admin user specific endpoints. So for that we are going to start with the backend first. Here you can see that we created this new admin package, and inside we have a controller and service. And we created this admin users controller, and this is going to be the controller that is only going to be available to users who have the admin role. We see that this endpoint will be served at /API/admin/users. And it will have only one method that is going to be called getUsers. We also see that we are using the pre-authorize annotation here, and we are specifying that the access to this method is going to be allowed only to users with admin role. But for this to work properly, we also made some error here in the user entity. When we were specifying the getAuthorities method, we actually have to prefix this with role underscore in order for that to work properly. Now going back to the admin users controller, we see that we are going to take in one parameter, which is going to be the page, and we are going to be returning this paged response object, which we haven't looked at before. So this is a new class that is going to represent the paginated response. So here we see that we have this constructor that is going to take in a page object that's coming from Spring Framework. So basically this will be the type that you get when you use repository methods with pageable, and we will see that in a second. Let's go back to the controller. Here we see also that we are injecting this admin user service, which we are calling from the controller method. So if we take a look at the get users method, it's only going to construct this pageable object with the page that was passed in. Then we are going to use the user repository find all. So what we want to return from here is the paged response that we just looked at, and here you see that we will be using this page object that we received from this find all method, but we are just going to map the values from user to user response. But now the only way to test this is if we have an admin user, which currently we do not, and we also do not have a way to add a new admin user. So for that reason we created this admin user seeder, which is going to be started on application startup, because this is implementing the application runner. And what we're gonna do inside, we're first going to try to find the user by this email that is coming from application properties get admin user email. This is a new property that we added to application properties, and this will allow us to specify one admin user that will be created on application startup. So here we will be checking if that user has already been created, and in case the admin user does not exist, we will create it and we will set the role to admin. We also had to add the setter annotation to the role on the user entity. And one more small change that we made is that we added a builder here to create user request, so we can easily create the request that we want to pass to this constructor. Then you should see a log in the console saying that the user was created with this email. So we will start the application, and in my case the log will not be shown because I already ran the application before and the user was created. But if we go back to Postman and take a look at this new request that we added, it's going to go to /API/admin/users. If we now invoke this endpoint, it's gonna return 401 unauthorized, which is what we expect because we are not authenticated. But if we go back to the login request and we send this one, now we are authenticated, but this isn't an admin user, so let's try with that. Now we are getting 403, which is again what we are expecting. Oh, but one more thing that I forgot to show on the backend is that we added this new exception handler that will handle the authorization denied exception. And this is basically what is going to return us 403 forbidden. If we haven't done this, we will not have the specific handler for this case and we would be getting 500. So now let's go back to the login request, and now we will use the admin details that we specified in the application properties. If we try to log in, we should see that it was successful. And if we invoke this endpoint again, it should also be successful. So let's try. And it is. So you see that here we added a new directory called admin, and inside we have this layout file. We also have the users page inside. But actually, before we take a look at this page, let's start with the layout file. And I mentioned this if statement previously when we were working on the profile page. And I said that if you are going to put this in a layout, then you will not need to check this specifically for every nested page. And that's exactly what I did here. So we are getting the user from our session, which is going to be stored in this use auth guard. And then if we are first time visiting this page, or we just loaded the page, we will not yet have the user data. So instead of showing the real content of the page, we will show the loading state while the user data is being fetched from the session endpoint. Now in the template here we see that we are using some new components that we defined. One is the permission guard and second is the role guard. So let's explain what those are, and here we see the comment that is explaining pretty well. So basically it says this is a component to show a permission denied message if the user does not have the required roles, and this should be used in combination with the role guard component. The role guard itself isn't made to show the errors, it is only used to hide stuff based on the roles. But in cases where you also want to show the message to the user that they need specific permissions, you can use this component. And I will show you how this actually works when we start testing. Let's also quickly take a look at the logic here. We are going to get the user from our session, and then we are going to check if this user has the role that was specified in the roles allowed. And we are going to assign the result of that computation to this isAllowed field. So then what we're going to do, if the user is allowed to view this, then we're going to just return null. So we're not going to show anything, but if user is not allowed, this code will be run and this will show the message permission denied, and it will also tell the user which roles they need in order to access this resource. And if we go over to the role guard component, we will see that it's very similar to the previous one. But in this case, what will happen if the user is allowed, then we will render the children of this component, otherwise we will not render anything. So going back to our layout file, what we can conclude from this is that any children, so any page that is going to be nested inside the admin directory here. Okay, so going back to the page here, we see that we are going to be invoking this endpoint that we previously created. It is going to be API admin users, and we are going to pass in a page. This is something that we will keep in state. And we also created this page response interface that is going to be replicating the class that we also created on the backend. And below that we see this simple markup with just this title, and below that we have a table. In the table we will show some user details such as ID, email, first name, last name, and a role. And at the very bottom we have this app pagination, which is a new component that we created, and that is just going to use the pagination components that are coming from the UI pagination. This is something that you will have to add from shadcn, but we are just going to display the next button and the previous button. And then we will have these callbacks that are going to be invoked when the next page or previous page was clicked, and also these properties that are going to control if the next and previous buttons are enabled or disabled. So let's go back to the page and see how it was used. So we specified the hasNext and hasPrevious properties based on the data that we received in the response. And then for the next page and previous page callbacks, we'll just be incrementing or decrementing the page state that we specified here. And this will automatically trigger the mutation of this request. So with that, we should be able to test this. So here at the login page, we are going to use our admin user details. So it's going to be admin@email.com, and the password will be password123. And here we see that this user does not have the logo or first name or last name or anything else, but we do see this new thing here in the navbar, and that is actually something that I forgot to show in the front end. If we go to the navbar, we see that we added this new admin nav component right next to the user nav. And if we take a look at the admin nav component, it is just going to be a drop-down menu which is going to show the link to the user's page, but it is also going to be wrapped with this role guard. So what this means is that it will not be shown unless the user is the admin user. And we will also see that in a second, but now because we are logged in as admin, we are going to see this. Later, when we log in as some other user that isn't an admin, we will not be able to see this. So let's now go to the users page, and here you will see the table that we just looked at in the code as well. It's pretty simple. We have this simple pagination, and we can navigate using the previous and next buttons. And now just to show you what that permissions guard component actually looks like. If we log out as current user and then we log in with GitHub, so this will be the user that is not an admin, so we do not see the admin drop down here. But if we now try to access this path, which is only accessible to the admin user, what we will see is this permission denied message. So we're almost at the end here, and the only remaining thing that we have to implement is going to be the CSRF protection. If you remember, when we were creating the basic authentication configuration, we had some to-do left to implement that, and temporarily our CSRF protection was disabled. So if you go to Spring Security documentation, and then in the sidebar you can click this cross-site request forgery link. Somewhere in the middle of this page you will see this single page applications section, and this will basically guide you how you can set up CSRF protection for your SPA applications. So this is the exact guide that I followed as well, and we ended up with these changes in the security configuration class. So these changes here exactly match what we just saw on that Spring Security page. So this is not something that I made up, but for the sake of it, let's just scroll through them. So here we are defining this token repository, token request handler, and a filter, and these two are defined below. In the same class we are creating the SPA CSRF token request handler and also the CSRF cookie filter. For more information about what is actually happening here, I would strongly recommend you to go to that documentation page and read it yourself. And with these changes implemented, if we go back to our Postman and we, for example, try to invoke the login request, this request would fail. It will not fail now because I have this XSRF token here in the cookies, but I have this token in the cookies because I invoked this CSRF request that I added, and that is basically also added here in the Auth controller. So we have API/Auth/CSRF endpoint that will basically just set the CSRF cookie to the response that can be later used by your client to send in future requests. So what we have to do now when we are invoking new requests, because this cookie is not HTTP only, it will not be sent automatically. So for example, here in the login request, we will have to go to the headers and we will have to add this cookie manually to the headers. So if we send the request now, we will see that it is successful, but if we turn this off and we try to send the request, we will see that it's forbidden. But if we go to the application and check what the actual reason is for that, it will say that the invalid CSRF token was found for the request. Now, with that said, there isn't actually that much that we have to do on the front end. You might remember that in the use Auth guard, we had this code commented out and this one as well. So we will be invoking the CSRF endpoint before we make the login request, but we will also be invoking the CSRF endpoint here in the root layout. So basically, as soon as the application loads in the client side, we will be invoking this endpoint to get the CSRF token. And if we take a look at our HTTP client, we will see that it is already set up, so it will include the XSRF token in the headers automatically. And before we test the application as well, we also forgot to add this request matcher for the CSRF endpoint. So for this endpoint, we want to permit all requests. So now if we open the application and, for example, we try to log in with this user, it should work just fine. But let's also try to log in with an admin user, so that will be admin@email.com and the password will be password123. That also works fine. If we go here to the admin dashboard, we will see that it also works fine. So everything seems to work fine, and with that I think we're done. You've made it to the end, congratulations. I hope you enjoyed the video and you found it useful. If you have any recommendations on how I can improve my future videos, please let me know down in the comments. I would also appreciate if you subscribe.